This is lesson 2.6, special functions. So we're actually going to end up kind of skipping around a little bit here. We are not going to write and graph step functions, but we are going to look at piecewise functions and absolute value functions in this section. So going to cut a little bit out of our notes. So let's go ahead and talk about what a piecewise function is. Notice the word piece here. So it's pieces. Pieces kind of put together. So what we have first is recognizing a dot versus a circle. So a dot, as you can see right here and right here, a closed or filled in dot on a graph indicates the point is included in the graph, meaning it could be equal to that. And then a circle that's open, an open circle, indicates the point is not included in the graph. So those dark lines mean it could be solutions, but then the open circle means it stops there and that point is not included. So let's go ahead and take a look at this piecewise. Go ahead and graphing this one here. So what I do to make it the easiest is to graph this line and then go back and erase. So you definitely want to be using a pencil. So to graph this line, we're going to start at -1. So we're pretending like this is our y equals x minus 1. So pretending like this is an equation here, just separate, even though there's really two equations in one. So y equals x minus 1. So we're going to start at -1. Put a dot, and we have a slope of 1 over 1 when it's invisible there. So up 1 over 1, up 1 over 1, up 1 over 1, and so forth. So we draw our line through those, and you definitely want to be using a straight edge to make sure everything is accurate. And we're going to go the entire length here. And again, making sure that you use that pencil is really important. Okay? So let's go ahead and look at its inequality here that goes along with this. So it's saying that x is less than or equal to 3. So that equal to means it's going to be a solid dot, like we talked about up above, at when x is 3. So let's go ahead and look at our x-axis, which is this axis along here, and we're going to find 3. So going to x-axis, here's 3. So I'm going to go until I find my line, and I'm going to put a solid dot at 3, which is my x value. And I want everything x is less. So everything less than is going to be everything that's going to the left, which should be everything going down. So I don't want anything up here, which means I'm going to use my eraser, and I'm going to erase anything that's above that red dot there, or your dot that you placed. And that's the first part of our piecewise. The second part, we're going to take a look at that next equation. And that next equation is the one right here where it's just saying that y, this is the same thing as y, right? F of x is really y, equals a -1. So that's the second part. And we can graph that line. That's going to go through the y-axis at -1. So that's going to look like this. And we're going to draw it all the way through -1, going through the y-axis. So now that we have that entire line drawn, we're going to take a look at the inequality that goes with it. So we want x greater than 3. So we're going to find 3, again on the x value. We're going to go to our line that we just drew, and it's going to be an open circle because there's no line underneath there. So an open circle at 3. And we want everything for x to be greater than 3. So if I look at my line, I think about which is going to give me greater values on my line, and that's going to be the right side. So that's the part I want to keep. I want x to be greater than 3. And then everything on the left I'm going to erase up to my dot, my circle. And we've just graphed it. Graph that piecewise function. So now let's go ahead and answer those questions about the domain and the range. Remember, domain is that span from here to here, all your x values. So from here to here, all those values that you could have are going to be your domain. So let's go ahead and just write that in there. We'll make it green to match. So domain, all your x values, put a little x. And then your range is going to be all those values that x could be. And I'm going to just make it this because I can see that it's stopping right there. It's all your y values. So that's your range. So let's go ahead and write in range real quick here. All right, so let's go ahead and answer this question. Domain, so I can see that I have this going on forever. It really is an arrow going on forever in this direction all the way to our negative infinity numbers here on x, and then it's going on, keep going, and then we're going to go this direction, and we're going to go all the way to positive infinity for our x. So that means if it's negative infinity to infinity, that also means all real numbers. So we can go ahead and write all real numbers. So let's take a look at our range then. Our range is definitely heading down with this line right here heading down to negative infinity for our y values, but it's stopping. See how there's nothing up here past that 2? So since that's happening, we're going to have all real numbers except for those numbers greater than 2. So how would we write that? We would write all real numbers less than 2 and including 2. Oops, 2. There we go. Alrighty, so we have our domain and our range listed. Let's go ahead and go the opposite direction of writing a piecewise function from the graph. So we're going to do very similar to what this looks like here. Oh, little announcement. Okay, so let's go ahead and oops, oh, that's connected. Oh well. Just write an equation for these lines, and then we'll kind of put it into the form that it's going to be. So since this is a horizontal line, it would end up, if it continued to head in this direction, it would end up going through the y-axis at 6. So that's if it were to continue to go on. So that equation would be y equals 6. And then down here, since it's a horizontal line and it's going through, or would, if it continued on the right there, go through the y-axis at -2. So it would be y equals -2. And then the equation for this line here in the middle is going to be y equals, and then we need to figure out what our slope is. So let's go ahead and identify what our slope is. There's a point, and where's another cross-section point? We'll use this one up here where the circle's at. So up 1, 2, 3, 4 over 1, 2, 3, 4. So it looks like it's a slope of 1. So we have a slope of 1. So we can just put an x there. And then where are we starting? So plus, where's our intercept? And we can see our intercept touching at 1 right there. So we can go ahead and put +1 there. All right, so that's our equation for that line. So now we're going to go ahead and fill it in like we had it written up above there. So we're going to have our f of x equals, and then we're going to have the symbol where it's going to mean including all of these. So just kind of a one of those fancy symbols there. So let's go ahead and write in, we have a 6. Now we don't put the y because really f of x is the y. And then we have in the middle there x plus 1. And then we have the negative 2. Now we do need to put in our inequalities. So that is telling us where it is, what it's including, and greater than or less than info. So for this one, where it was the y equals 6, we look at our x value. So we're always going to have our x here, and we'll write this in a different color for you. So we're going to have an x. Since it's a solid dot, we know that we're going to have the line under our inequality. And we are greater, so x is greater than, and at what number is x at? So we go from the dot down and look to see what our x value is, and it's 4. Then for this one, we're going to have actually 2 values. So that means x is going to be in the middle, x is going to be less than, and x is going to be greater than something. And it looks like we have a solid dot for when x is going to be greater. So we're going to put that line under there because we have the solid dot here. So what are the 2 numbers it's between? So again, we want to look at our x values. So this number right here, which you can't really see it because it's covered up, is a negative 2. That it is greater than or equal to. And then up here, this number is 4. So 4 goes right there. And then lastly is going to be this line here, and that one is at x is, and it's less than, because we're going to the smaller side here, and it is less than negative 2 for our x value. So we're always looking for our x value because that is what it's saying. And that's it. So go ahead and try number 2 on your own. Again, just write the equations for those lines and then plug it in and do your inequality part. So you can pause, try those on your own, and then you can always double check. All right, so if you are ready to check, it should be f of x or g of x or whatever you wanted to name it, with your little squiggly here to include all your parts. And it should be up at the top there, that would be 1 going through the y-axis, and then x minus 4. So slope of 1, and its intercept is negative 4. So for this one, x is greater than or equal to 2. So there's a 2. And then for this one, x is less than 2 and not including. All right, last thing we're going to talk about, so again, we're skipping the step functions, and we're going to look at absolute value. So what we're going to do is just in the back of your notes packet, so I'm going to move that up out of the way. So go ahead and flip to the back and find section 2.6. We're going to look at example 4. So all we're going to do is plug in numbers for x to figure out what our f of x or our y would be and plot those points. So I kind of already set up a table here. I'm going to plug in negative 2, negative 1, 0, 1, and 2 in for x. So here I did plug it in, and then I simplified it. So negative 2 minus 6 is negative 8. Absolute value of negative 8 is positive 8. And so forth, and went through. So my ordered pairs are going to be my x value, which is what I plugged in, and then my f of x value, or my output, as the y value. So we can go ahead and now plot these points, and as you noticed above, an absolute value, it kind of forms that V shape and has that, so we should have that V shape as we plot these points. So it's not going to be all of them, there's definitely a lot more, but we do want to make sure we've got that V shape. So let's go ahead and plot these points. So negative 2 going up to 8, negative 1, 7, 0, 6, 1, 5, and 2, 4. All right, so we're going to plot our point and continue on. You might have to plug in a few more values until you get your V shape and then draw your lines.